Hi, I'm Paul. We're doing Leetcode Must Know interview questions. Today's challenge, bitwise and of numbers range. So given two integers, left and right, that represent the range, return the bitwise and of all numbers in this range, inclusive. You might say, why is that medium difficulty? I mean, we can just and all the numbers in the range. But see, here's why it's medium, because the numbers can go up to 2 to the 31st minus 1, which I think is this number right here. It's 2 billion something. We can't do 2 billion and operations in a reasonable amount of time. So what we're going to do is we're going to do this in a bitwise fashion, meaning, an integer has 32 bits. So at most, we would do 32 operations. We can work through an example of that to see how it would work. None of these examples are very interesting. So let's use 10 and 15. First of all, let's see what the answer is if we AND all of those. So 10 is this, 11 is this, 12 is this, 13, 14, and 15. All right, so if we AND these, we're going to get 1, 0, 1, 0. Okay. Now if we AND that with the 12, we're going to get 1, 0, 0, 0. And at this point, we can see that the only bit that's common to all these numbers is the high order bit here. And so the answer is going to be this, which is 8. So that's really the key insight to this, is that the answer is going to be the bits that all the numbers have in common. All right, let's see how we could implement that. Probably should pause this while I'm erasing. But all right, so left and right come in. I'm just going to use L. And again, we'll use the same example. Left is 10. I need a little bit more room for right, probably. Right comes in, and it is 15. Right? Now, what we'd really like to do is kind of strip these bits off one at a time, starting with the low-level bit. So why don't we take right minus 1, which would be 14. 14 is 8, 12, 14. All right. Do an and assign the result to right. So the result is going to be 1, 1, 1, 0. We would have to AND right with 14 because 14 is in the range. Okay. Now, Let's try 13. Again, we're going to subtract 1 from this. And so subtracting 1 from 14 gives us 13, which is 1, 1, 0, 1. Now, if we AND these numbers together, and what we're trying to get to is we're trying to get to a number that is not in the range. We're trying to get to a number that is less than or equal to left. So if we AND these numbers, 14 and 13, we're going to get 1, 1, 0, 0. Okay, now we're down to 12. Subtract 1 again. We'll get 11. That is 1, 0, 1, 1. And these numbers together. Now we have 1, 0, 0, 0. And that is less than this. So this is the answer. We've found the only bit that all of these numbers have in common. So that's the way it works. It's a simple implementation as you're about to see. Okay, so as I said, what we're going to do is we're going to loop through this process as long as left is less than right, meaning that we're still working with numbers that are in this range, the range from left to right. And we are going to say right, and we'll do an AND equals of right minus 1. Now, all these numbers are in the range, and we're just trying to find out what bits do they have in common, and what bits do they not have in common. You know, I guess that's probably closer to the right thing. What bits do you know what? I don't want to say that. And then return right. Okay, at this point, right will just contain will contain the bits that all of the numbers from left to right have in common, because we have zeroed out the bits that they don't have in common. So let's try it. All right. That's good. I mean, it's good that it works. These are really simple, except for 3. The problem with 3 is that if you did it in like what's usually called the naive method, but I mean, I don't like that term. Let's say if you did it with the obvious method or the intuitive method, I'll just AND the whole range. That wouldn't work with this. So let's go ahead and submit. And what did we get? Did I submit that? Oh my gosh, it came up over here. Okay. So we have three milliseconds, which I guess is the best that you can do. So I hope you enjoyed that. I think that was the last bit manipulation question in the top 150. Feel free to like, comment, subscribe, and see you next time.